Hello friends, today we are going to talk about how we can measure temperature and what scales exist in order to determine the value of this temperature. In fact, you can measure the temperature in different ways, and in fact, based on this, you can find in your life different types of devices that can do this, to do that. But in general, you and I can summarize the fact that all these devices in one way or another will display the temperature in some units of measurement, that is, respectively, in some scales. And here are such scales. To date, we have three main scales in which, in general, you can meet the measured temperature in your life. Well, one of the most common scales in nature and in the world we have is the Celsius scale. Celsius invented this scale by drawing on the most common substance in nature, which is water. And in this case, water is a kind of benchmark against which he built his scale. So, what are the reference or so-called reference points for this scale? First of all, these are two phenomena that occur with water in nature. It is its freezing and it is its boiling. Two temperature points at which these processes begin, and we must note that we record these processes at normal atmospheric pressure, that is, at sea level. Because as it turned out, the same boiling point depends on external conditions, and water will not always boil at the value of the temperature that we will now indicate. So, if we look at two processes, this is the boiling of water and the freezing of water. In this case, the two processes occur at their own temperatures, which Celsius took to be about 100 degrees. That's the boiling point of water, and 0 degrees, which is the freezing point of water. Then the gap between these two temperatures was divided by 100, and so we get a value of 1 degree Celsius. Then of course you can go up and down, so let's just say there's no limit for this scale upwards, which is the maximum temperature according to this scale. But there is a minimum temperature at which this scale stops, and below that temperature, you and I can't fix its value. This is the lowest temperature in nature, and we will talk about it a little later. This is how the first temperature scale is formed, which is used in many countries around the world. The next scale that we will consider with you today is the Fahrenheit scale. The Fahrenheit scale is based on slightly different phenomena, and Fahrenheit himself was based on slightly different processes when he built his scale. Scale, it was his view of temperature measurement and how it would be measured and in what units it would be measured. So, what were the main reference points that Fahrenheit based his scale on? Well, he took the lowest temperature to be 0 degrees on his temperature scale. That's the temperature that he was able to achieve in his laboratory, the lowest temperature, and it corresponds to about minus 17 degrees Celsius. That was his laboratory lowest temperature at that time. And the second temperature he took as 100 degrees Celsius on his scale, that's the temperature of the human body. But after refinements and some equalization, the human body temperature is still not exactly 100 degrees Fahrenheit, but it is 98.6 or so. But if you look at the points we've made here, which is the boiling of water and the freezing of water, in this case on the Fahrenheit scale. Water boils at a temperature 212 degrees and water freezes at a temperature 32 degrees Fahrenheit. These are the 2 points that we can match up with you between these two scales. And as you and I can see, the range between the Celsius temperatures for the same process and the range of temperatures on the Fahrenheit scale, they do differ. So here between the boiling point and the freezing point, we see a 100 degree difference, and here we see a 180 degree difference. That tells us that the two scales are on different scales. So to convert the temperature from one scale to the other, we're going to need to get a formula. How do we do that? Well, given that the starting, let's say we can see the temperature, it's at a different level. So in order to get the temperature in Fahrenheit, we have to, take into account that the temperature starts at 0 here. If we go up, it's 32 here. So first of all, we add 32 degrees right here. And plus, we have to take into account the fact that the degree measure, which is the scale value, they're different. And if you calculate how many times they differ from each other, you can see that here we have a range of 100 degrees, here we have 180 degrees. So the Fahrenheit scale is 1.8 times larger than the Celsius scale. The Celsius scale, so we just have to multiply that number by 1.8. And that's how we get the formula for converting temperature from degrees Celsius to degrees Fahrenheit. And the third scale, which is more common in science, which is generally all thermodynamics, is based on this scale. And so therefore it's going to work on the basis of Kelvin's scale. Kelvin proceeded from the fact that he had fixed the lowest temperature as the temperature below which, in principle, nothing can move, so that stops any movement of molecules inside any object. This is the so-called absolute zero temperature. And below this temperature, if we have nothing, then this temperature scale has only a positive value, unlike the Celsius scale or the Kelvin scale. So the lowest temperature on the Kelvin scale is exactly what we're going to track. The lowest temperature on the Celsius scale, which is minus 273 degrees. So what we're going to show you here is that this temperature has its own value. 0 degrees Kelvin. And by drawing further parallels, you and I can show you that for 0 degrees Celsius or 32 degrees Fahrenheit corresponds to a temperature of 273 Kelvin. And so here, respectively, this temperature corresponds to a value of 373 Kelvin. Proceeding from this table, we see with you that the range between 2 points on the Celsius scale and on the Kelvin scale is the same. What this tells us is that the Celsius scale and the Kelvin scale will have the same degree value. The only thing we can see is that to get the Kelvin temperature, we have to add 273 to the Celsius temperature. Given that here we have 0, here we have a value of 273. So that's the only difference between the two. Well, they have the same degree value. Thus, 3 scales exist today. And now you know how we can translate temperature from one scale to another, i.e., work with different units of measurement. Well, in order to determine how to measure temperature, in order to do this, of course, you need to study the device of various thermometers. So these are instruments that are based on different properties of substances. And one of the most common thermometers that we use in our lives is the liquid expansion thermometer, which is based on the expansion of a liquid when it's heated or cooled. We will talk about this in the next lesson. That concludes our lesson. Goodbye, everyone.